Hey guys, what's up? Welcome to the channel. Turbo John here. Car's been down. We just got off of a great weekend of racing. Well, we had fun anyway. We weren't real successful with the car. We had to work on it a bunch, but it is what it is. That's what we do, is having fun with Randy's car. Mine's been down for a little while. It's coming back together, but while it was down, I want to talk to you guys a little bit about turbo. And you guys know which turbo I have. It's one of the baddest in the country. It's one of the baddest in the industry. It's a Forced Inductions GTR 102. So Lil John at Lil John's Motorsport Solutions and Jose at Forced Inductions. You know, I've been getting parts for them a long time, and you know, there's some great dudes. So I wanted to just show y'all exactly how this turbo is. It's a monster. It's a huge, gigantic turbo, 102 millimeters. But I need to pull it apart. I just busted a piston and I dropped a valve, so I had a lot of material. So I need to pull that turbine housing off and just make sure there's no material in there. Make sure there's not any real big damage to the turbine wheel. I saw a couple little dents and dings, but I think it's going to be okay from, you know, looking at it through the extruder part on the turbine wheel. So anyway, I just want to show y'all the measurements, style of wheel it is, and show you some of the things that these turbos have, and a lot of people don't know, and a lot about the dimensions of it. So check this turbo out. It's bad to the bone. Go to the link below and get some t-shirts. We got some swag if you're interested in getting a t-shirt. We got gray and blue. They're really lightweight. They're really cool. I appreciate y'all's support. Thanks. I'm just like everybody else. If you see it in there, you got to spin it. You always got to spin it. This is the face of the turbo, of course. This is what everybody sees. This is what everybody is familiar with. And there's a few things you can pick out right off the bat other than, you know, this thing is just a monster. It is huge. It is a big turbo. You see the word Garrett. This is a Garrett turbo. So that is the base. That is the base that Jose takes and turns it into his GTR. And one of the things he does, the biggest thing is he takes this cover and he matches it with his custom compressor wheel. And these are all cut in-house. And, you know, they have different styles, different shapes. A lot of people always ask, you know, well, what is the difference between cast and billet? The billet wheels are just, they give the ability for the manufacturer. They can get airflow, they can get dynamics, they can get everything tuned exactly right. And it's going to be more sturdy. It's going to be stronger. It's not going to be as weak as a cast. Billet wheel is going to be thinner, so it's going to be able to flow more air. But you can see these things, there's some tricks in here. And a lot of these tricks, a lot of people know. I mean, all the manufacturers know them, and they all do little things. And Jose is one of the ones that is very innovative, and he thinks outside the box, and he does a lot of things. And these three holes here, what they are on mine, we were running a local class, limited 28s. And those rules required a turbo that had a 98 millimeter reducer on it. So I had a reducer on this, and didn't really slow the car down a lot. Reducers really don't do a ton. But one of the biggest things, so that's what people see the most. They see the compressor wheel, and then they see the compressor housing here. Of course, what this just goes to the bottom side of the wastegate, and that's what helps control boost there. But part of the turbo that people don't really think about, you can see the center section. This is a ball bearing center section. This is a Gen 1 Garrett. But the turbine wheel, the turbine housing, all this stuff makes a huge difference. This piece right here, this is what I would go to my back pressure reading. So this is very important. A lot of people don't read back pressure. They just keep turning the boost up, turn the boost up, and then they wonder, okay, well, the car's slowing down. I don't understand why the car's slowing down. But it may be that now you're getting a lot more back pressure than boost pressure. So you have to, you know, stuff you need to monitor. And you can see my handy dandy little drain flange. There again, I'm not a welder, I'm a grinder, but I did weld these little stubs out. And this thing's been, I think this drain has been on almost all of my turbos now. And of course, these little fins here, these are just to center cool the section. Not all of them have that. Some of them do, some of them don't. This is a ball bearing turbo. One of the ways you can tell ball bearing from journal, I mean, other than obviously, you know, how easy it spins, this thing is cold. It hadn't had oil in it in a long time, but you can see it still spins really easy. But what I noticed is on mine, on this one, if this flange is off, then if you look down in there, you can see there's a bolt that goes in there, and I assume, I've never had a ball bearing turbo apart, I assume that's what holds the bearing center section in place. But it looks drastically different than a normal journal bearing style. So let's quick talk about ARs. So AR stands for area and radius, and you see this is a 0.96. The higher number this is, the bigger the scroll is, and the more air it can potentially flow. And so that's one of the things. This turbo, when I first got it, it was a 98 millimeter, and it had the 11 blade all billet wheel on it from Garrett, and it had, I think it was a 0.81 on it. And so, you know, some of these have a 0.69, and so the bigger this is, the bigger the scroll is. As long as it's fitted to the right compressor wheel, it's going to flow more air, and it's going to be more efficient. So that's one of the things your turbo manufacturer, you know, they do, your turbo builders, they do that stuff for you. And I don't know if y'all remember it, people that have messed with Borg Warner turbos, the S400s, when they first come out, they had a regular cover on them, and then they come out with the John Deere race cover, and then the version 2 race cover. And all those covers enhance airflow. And so that's one of the things that you have to be, you know, you have to watch out for, you know, when you're looking for turbos, you know, what compressor cover is on it. And sometimes there might be an option to have one that has, you know, a bigger AR on it. Now, the turbine housing everybody is familiar with. Now, this turbine housing, when you buy a turbo from Garrett, when you buy one from Jose, he's going to get you the right turbine housing. When you buy it from Garrett, they sell you just a center section, and it does not have a turbine housing. So when you call up Lil John or you call up Jose and you say, I want, you know, a GTR 102 or a GTR 98 turbo, then one of the things they're going to ask you, do you want a turbine housing or not? And if the answer is yes, then they're going to say, they're going to get some specs from you. They're going to say, well, how big is your motor? What's the RPM range? They're going to talk about camshaft design. There's a lot of information that goes into figuring out what turbine housing you need. Now, the bulk of the turbine flow is going to come from the size of this turbine wheel. So, and the shape of it, the way it's laid back, if it's cut back any. But you have the exducer, which is the part you can see here. Now, this is opposite from the compressor wheel. So this is the exducer, and the inducer is going to be on the top part. It's going to be the major diameter size. And so what happens with this thing, the bigger the wheel, the more flow it's going to have overall. And the area, the AR, this is still an AR set up on the turbine housing. The AR on the turbine housing is going to control the spool up characteristics. So this is a 139 housing, and this is off of like an old TV, older Garrett, like a TV 8101. The exducer on this wheel was the same as the exducer on the other one, but the inducer was drastically different. And I'll show you, I'm gonna take this apart because there is a little bit of aluminum in there from that piston. So I've got to take this apart and clean it. So I'm gonna just show you what the difference is, where we had to cut this. This is a GT55 turbine wheel. GT series turbo, they go on number base. So you got a GT40, I think they start off at a GT, I think I've seen some 25s, but mostly like 38, 40, 42, GT45, GT47, everybody is familiar with. People have heard that forever. And then you got GT50, which is not quite as common, but it is still out there. And then GT55 and GT60. The GT55, this is like the Pro Mod stuff that Precision modeled their stuff after. You know, they made some tweaks and made it their own, but that's essentially what it is. But so the turbine wheel is in all of those is the higher the number, the bigger the turbine wheel. Now those old large frame turbos, like I blowed up the 106 and the other large frame 98, they have F trim and G trim wheels. And what they are, the exducer is really huge. It's 127 millimeters. And then the F trim wheel here is a little bit smaller than a G trim. But I think they're still like 110 or 114. I don't remember those numbers exactly. But, you know, they're huge. But on my motor, so I've got a little baby motor, but we know that the bigger AR this thing has, the more it's going to flow. So generally, as long as you can spool it up good, and as long as the motor has enough, you know, horsepower and enough torque down low, and a lot depends on your fuel. If you're running methanol, it makes it a little easier versus gasoline. But as long as you have enough horsepower and enough torque, and your tune is good, and you can spool this thing up, the bigger AR you have, as long as you can leave with enough boost, generally the car is going to be faster. Now, this ball bearing turbo helps with spool up and transient boost a lot. So you can't ever leave at full boost. You won't ever be able to leave at 45 pounds of boost. It'll just destroy the tires. And so you have to leave at, you know, somewhere between 8 and 14 pounds of boost. It depends on the motor. It depends on the suspension. It depends on a lot. There's a lot to it. There's a lot that goes on to make these things work. And so the boost, you've got to be able to reach max boost in a reasonable amount of time. So if that turbine housing over here, if you got that 139 turbine housing and say I'm leaving at 10 pounds of boost and I'm commanding 40 pounds of boost at 1.5 seconds and it takes 3 seconds, then that's not going to work. You need to go down in turbine housings, and that's what people do. And so, you know, they make for this particular 112, they make I think a 112, a 124, and a 140, and mine's, like I said, mine's a 139. So that's the turbine housing side. Okay, so I'm gonna take this compressor, these housings apart real fast, and I'm gonna just show you the different measurements and different things they do to make these things flow. And one of the things I'll go ahead and show, and you know, there used to not be any rules with this stuff. The diesel world has been doing this for ages. But this surge slot back here, this is a surge slot. And what this does is if this wheel is moving way too much air, then what it does is it allows some of that air to be recirculated out the front. It just comes out the front. And it also helps like in shutdown. So when you let off the throttle at wide open throttle, if your blow off valve is open, but it's going to start stalling possibly, and it's going to backflow. It's called a surge slot. But what the turbo manufacturers, you know, learned at some point, and they all do this, is this surge slot here is widened, and at very high efficiencies, you know, when the turbo is making a lot of power, when it's at a certain wheel speed, not only is the air going to get sucked into this front, it's going to get sucked in through the surge slot. And so almost every company, they play with these width. And so I don't know how much horsepower it adds. I mean, but they're, you know, that's above my pay grade. But I mean, it makes a difference when you're, you know, messing with this stuff. When you're tweaking the surge slot angles, when you're tweaking the surge slot size in relation to the tip of the compressor wheel, there's a lot of differences. So there's, you know, some of the older turbos had the holes drilled, and all that was a surge slot. But those are ways that, you know, people are tweaking the turbo rules to get more power. So, you know, Jose is one of the best. I mean, you know, forced inductions, they are, in my opinion, they're probably the most innovative turbo company out there. Jose is constantly refining his techniques and his, you know, angles and the blades. He's able to CNC machine these blades in-house. So they will come up with an angle, prototype it, R&D it, and then they'll put it into work. And it'll go on somebody's car for actual real-world testing. So before you get a turbo, before you buy one from Lil John or from Jose, it's been tested on somebody's car, and it's going to make more power than they're going to tell you. It's going to make, you know, this upgrade is worth X amount of power, or this upgrade is worth this amount of power. And, you know, sometimes they'll tell you, okay, well, you know, I can sell you that, but that's not going to make you any more power. So, I mean, it's one of those things you have to, you know, you have to listen to your turbo, the people that you're trusting to do this. And so it's amazing stuff. So this is part of the compressor housing, you know, these surge slots. And there's a lot of trick stuff in there. Sometimes you'll see these things tapered way down in size and in the hub. And, you know, it's just crazy. The shape and angle of the blades. This is a older one. This one's the older style. You can see the angle blades on this now are straight. His newer ones have a more of a back sweep blade. And so, you know, there again, they've come up, and you can see the way these things angle down. And I don't know if y'all remember the old, like, Pro Chargers back in the day. These things were just straight. They weren't back swept. They weren't curved. And they didn't have much airflow. But now, you know, even the Pro Chargers and Vortex, they're taking the shapes from these. But let me show you more about the sizes real fast. Okay, so I got the compressor cover off real fast. And you can see this thing is being machined out. There you can see that map groove there. This just held on with a V-band. Most of the turbos are now, all the compressor housings are done with a V-band. Most of the turbine housings are done with a V-band, but some of the older stuff is not. So one of the ways you can tell a billet wheel is you can see all the wheel marks. And they leave those in there for a reason. You can see how they got it nice and smooth on the face of the wheels. And you can see this is a threaded hub completely. But that's always, you can tell. Every billet wheel I've ever seen has always got this, and it's got the different texture to it. So that's a way you can always tell if you've got a billet wheel. Now this particular billet wheel, this is a 7+7 design. And so what that means is there's 7 inducers. So 1, 2, 3, 4, 5, 6, 7. And then down in there, the little splitter blades, there are 7 of those. And so that's just the way this wheel is designed. And so that's a bad to the bone compressor wheel. So if you measure this one, like I said, this is 102. One of the things that people used to mess up on when they were first doing it, a 7+7, of course, the wheels are not across from each other. So if you measure from there to there, it only reads 97, less than 100. So that may be in the realm of your rules. And so in order to get this, you would have to have a bore gauge, or you have to have, you know, something where you can go down a little deeper. And if you go down a little deeper on this one, to where they're almost side by side apart, you can see it's like right at 102. So maybe a little bit over, a little bit under. So that's the way this thing works. That's the way the inducer. So this is what everybody knows. This is the size of the turbo, that inducer. So what a lot of people miss is the exducer. And you can see this thing has little wings, and they call this an extended tip. And what the extended tip does is it's supposed to enhance the width of the map. So it's a bigger circle in the middle. But the exducer is the actual big part down there. And my dial caliper is not deep enough to go down in there. This is a little cheap Harbor Freight dial caliper, but I'm gonna measure that for you real fast too. So since my dial caliper is not really big enough to go down in there, it's a guess. It's somewhere between like 140 and 145 millimeters. I don't know what it's actually supposed to be. Compressor wheel, the inducer and the exducer. So now let's look at the turbine wheel real fast. Okay, so we got turbine housing off. And you see I did have a little bit of aluminum that was in the turbine housing there. Not a lot, but you can see this is where we machined it down in here. This width here was a whole lot wider on this turbine wheel. So this inducer part down here. So that's what we had to cut out on that turbine wheel. So looking down at the turbine wheel, you can see this one has a really big hub in the middle, and sometimes that can be modified as well. But one of the things you want to look at is the number of blades. This one has 10 blades on it. And you can see they're back swept. And if you look through, if you're looking straight down through it, you can see this goes all the way down. You can see the backing plate down in there. And that's a back cut. And that's what, you know, people used to talk about clipping wheels all the time. A lot of manufacturers now do it from the factory. And if this one was not clipped or back cut, then this would go straight out, and then it's not going to flow as much. Now, looking at the sizes, this is opposite of the compressor wheel. So now, down here on this side, and you can see I've got a few little dings in it. It's just, there's no chips, and they're just offset. So this is going to hurt flow and efficiency just a little bit. But it's not, it shouldn't throw it out of balance or anything, since nothing is missing. And that's where those pieces of aluminum went through there. But so what's going to happen with this thing is this is now called the inducer. And because that's what the gases, the exhaust energy hits first, it hits the big parts of the blade here, and then it spins it and then flows out. And now you can see when you get down at this angle here, you can really see the sweep. It comes from here and goes down, and then it also clipped is what they used to call it. And they have, you know, different degrees. The turbine wheel is super important. A lot of people used to not really think about turbine wheels. They were thinking, okay, well, turbine wheel is, you know, I can get by with a real small one. If you have a very small engine, then that is correct. So if the engine is small and you got a great big compressor wheel, then you might be able to, you know, get by with a smaller turbine wheel. But the bigger turbine wheels for bigger engines is always going to be ideal. It's got the, you know, you can't just force it in there through the compressor. It's got to get out. So the exhaust has got to get out. So this turbine wheel is what dictates how quickly that's going to get out. I thought I saw a dent way down there, but it was not. It was just a finger mark. And you see my little greasy fingers. Man, this is dirty. It's been on the car. What do you expect? Anyway, and you see these little offsets here. It looks like it's bent when it's spinning. This is balancing. That's where they cut it off when they're balancing it in the balancer. So they balance it, and then it shows where they need to grind it to get it so that it spins. It's just like a tire balance. So instead of adding weight to it, though, they just cut weight off wherever they need to. So that's what that is. All right, guys. Well, this is a GTR. Like I said, this is a GTR Jose forced inductions turbo. I just wanted to show y'all kind of the layout. I mean, a lot of people know how turbos work, but you know, a lot of people don't know the inside working of it. So this turbine wheel, the GT55, if you measure it on the outside, since this is 10, they are directly across from each other. 102 millimeters on the exducer, and the inducer, I measured it a few minutes ago, 111 or so on the inducer. So 111 and 102, 103. So that's a GT55 forced inductions turbo, Garrett based. All right, guys, if you guys will like, comment, and subscribe, I appreciate it. Go to the merch link below, get you some t-shirts, and we'll ship those things out. Thanks.